Nope, not yet.
Okay. Have you been in touch with Joe at all?
Yeah, I haven't contacted him yet, but I'll do that.
Okay. Good.
Speaking of. Hi,
Yeah.
Joe.
We were just speaking of you, Joe. So Devin was saying that he implemented your branch, but didn't notice very much change. Joe?
Hey, what's up?
Yeah.
Oh, I was just saying, Devin said that he just implemented your branch for the 2.5D inversion, but it didn't really make very much difference for him for running.
Yeah.
So that means probably a decent more amount of time is spent like doing the inversion side of it. I was just working on getting the DC simulation itself running faster. So it's
Yeah,
like it's possible that a little bit more work is being done on the inverse operation.
Yeah, and I think I got some notable improvement for the forward solve, and I was working on simulation DC 2.5 speed up.
Yeah.
But I didn't reduce the size of the problem to 30% of what I needed. It was more like 60% of what I needed.
Mm-hmm.
So noticeable, but not groundbreaking, but still a notable improvement.
Yeah. Like I said, it was mostly just to pass through it some low-hanging fruit on things that could use a little bit of speed up, and things that I saw that were slowing down.
Yeah.
Or anything else is gonna the next step is probably a little bit more will be more involved.
Okay, well, let's maybe start with going around the room, and then we can regroup back on the DC if that's the priority for today. Yeah, but I see Joe and Colton first. So would you both like to say hello and give any sort of update you have?
Sure.
Colorado.
I kind of got down here yesterday. Spending some time with Liz, going around working on stuff here. I've been working on getting all the method names updated. I've been pushing a few changes on that as far as kind of deprecation generator things, meaning instead of having to write out, okay, this will be deprecated, the warnings every time, just kind of automated generators for those functions, and I've been switching almost everything over to that.
Nice.
So one of those things, like we can go through and just remove those and also go through and update all of the points at which they will be deprecated. So that's something I'd like to talk about or discuss a little bit today. So all the changes from simulation, I'm doing my best to kind of keep functionality of what was previously there, but it's like we have to kind of decide on the point at which it will break. So maybe that's like SimPEG 1.0 will just remove all the deprecation, or it's sooner than that. Just some things to think about. Can always be changed in the future. Yeah,
I would be tempted to break it before we do a SimPEG 1.0 release to at least have some time to iron out the kinks and not have the release of SimPEG 1.0 be a giant frustrating thing. Hopefully it's a very exciting thing.
I agree.
I don't know if other people have sort of instinct or gut reactions to that.
I just didn't know when, and right now as a placeholder it said it's 0.15, whatever that's gonna be.
That sounds good.
Okay, what is it in the future? I don't know.
Yeah.
I was thinking okay, are we gonna even have a 0.15? Okay, outside of that, I can go through some of the DC 2.5D or the DC stuff I was working on to kind of show at least a little bit of improvements I was able to make and things, but I can go into that more later when I discuss other people's stuff.
Excellent. Okay. Thanks.
Oh, my turn. Sure. Yeah, so I'm back to EM modeling. time domain EM, and it's been going great. It's really exciting to see that what we expect the physics to be doing is actually being reflected in SimPEG. So
That's wonderful.
yeah, intuition is matching the data. So hooray, that's great. Joe's kind of been talking to me about the simulation branch. It sounds like cool changes. I know I've heard some of them just floating around in these meetings. That's fun. And I'm at the point where I'm going to start doing a parametric conversion, but I don't know if I'm going to actually use SimPEG as the driver for that, or if I'm just going to code it up in kind of its own thing, just because it's a very simple problem, and I don't think it's worth going into and using SimPEG for all of that.
Cool. Well, I look forward to seeing what you come up with, and maybe somewhere down the line you can show us some images and results. But no pressure. Just whenever you got some things you're happy to share. It'd be awesome. Cool. Well, I see Saki next.
I went to Calgary last week. Gave a talk, and yeah, I met a number of people actually using SimPEG in University of Calgary. So that was pretty good. Yeah, actually, I'm not sure what I'm doing. I help a couple of people. So there seems like more needs in like time domain EM code, but people are absolutely struggling how to use. And yeah, so I was helping a couple of people, like Peter was trying to use for his marine EM example. Now he's got he seems pretty happy with the step off, but he wants to model impulse function, which I'm not. So I let him know how to do that, but I think we are having a little bit of issues. So, and the other example, is this Italian girl working on the loop system, but yeah. So how the current time domain code works? It's working, but as an outside user, it's very hard to understand what's going on. And yeah, I don't really have a good solution about that. I'm fine with working, I'm fine with using it, but all this idea of time discretization and it's not very intuitive, and it's actually also, what was it, Joe?
I'm gonna say it definitely requires a lot of understanding of.
Yeah, exactly. So I'm expecting them to have a hard time, but this girl was spending a year trying to use SimPEG and not getting a single inversion result right. So yeah, I thought that's kind of pessimistic, and I don't know. So I mean, it seems the only way is writing a good tutorial and making a good example. Yeah. Other than that, I was not quite sure.
Yeah, so I've seen that too. There was an example that Dieter sent along that he was getting really frustrated with, and there were just two things that were slightly wrong. As his padding didn't go far enough, so there were boundary condition effects, and then his time discretization coarsened just too quickly at the end. And yeah, those are subtle things to pick up on, but in the tutorial side of things, I guess those are things to totally highlight. Yeah, because it's hard to guard against all the potential things that the user could do wrong.
Anyway,
for now, Sugi, has all this help you're providing been doing through Slack or Discourse or GitHub issues, or is it just personal emails?
Yeah, can you repeat, Thibaut? I wasn't getting it.
For all the help you're providing right now to all those people, are the exchange through Discourse or GitHub issues or Slack or personal emails?
Yeah, I'm trying to encourage them to post on this course. Yeah, but I think not all of them are coming into the surface, I think. And sometimes I'm just giving like a simple solutions like, oh, I fixed those parameter in the notebooks, try that. Um, so hopefully at the end, like if they can put together like at least like a single notebook that runs and shows how they solve the problem, that'll be nice. So we're keep asking people to do it, but yeah, not exactly sure, but yeah, like not sure we have a good use cases and examples, but that's a hope.
Okay.
Dom, I see you next on my screen.
Hey guys. I just pushed a test and clean up an example for the tile map. So there's a pull request onto simulation, and Joe asked for it. So I did this. I can demo it to you guys after if you want what the example looks like. It's pretty simple, but it does the trick. And then the test should cover basically that simple map.
Yeah.
So go ahead. Yeah, Joe.
Thanks for doing that.
Yeah, no problem.
I had a quick look at it. I was just kind of curious, is it necessary to do the iterative weighted least squares as part of the example?
No, we could do straight up pick enough. Yeah, is that better for you?
I mean, I'm just saying if it runs quicker, and it's not.
There's 0 iterations on it, so it will quit.
Okay.
It will quit right away. Yeah.
Okay, never mind then. Probably fine.
Yeah, it's just L2. Other than this, I'm doing more GUIs for 1D frequency and time domain EMs for our sponsors. That works really well. I'm still getting a lot of mesh effects though on the connectivity model, so that's kind of like what I'm working on right now. Other than
in 1D though?
Yeah, the stitched 1D. Yeah. Every time the mesh increases in size, you kind of have a discontinuity when it changes. You know.
Okay.
And I've tried Tikhonov, I tried Sparse, I tried them all, and yeah, I just can't make it disappear.
How are you? Yeah, how are you vertically discretizing? Like it's just a vertical discretization, right? Like.
Yeah, so I was doing like a block of constant cells, let's say 10 meters, and after this an expansion factor.
Yeah, so what's a typical use case in here is just like using like a sum factor, like 1.1. You start from like whatever, you define whatever the smallest cell size, and then you slowly increase like 1.1 is a factor that I'm using. But yeah, with that, I haven't really seen too much of the mesh effect. Yeah, I don't know, but that's what we're doing here.
Yeah, maybe I'll generate a small example and we can look at it together. Because I mean, even if you just do an expansion, you have a tendency to have the reference model kicking out strong and the paddings, right? So you basically have like a mesh dependent solution. It's not great.
Okay.
We can look at it.
Sounds good.
Other than this, we're starting to get a lot of traction here. There was desire to push the CSC-MT. I saw a guy ask you, right, if you wanted to work on it. MT as well. So I think the next couple of months we'll need. I'm going to personally put a lot of working hours on those codes, and if anyone wants to get involved, they could be like financial support for it. That's it for me. Yeah, that's it.
So Dom, I just got a quick question. So tile map is like basically handling the interpolation, right? Interpolation between like a global to local mesh. Is that right?
Yeah, for the model and the sensitivities, yeah, back and forth. Yeah, it's the same projection matrix. Yeah.
Right, and then are you doing like a kind of UBC style, like so you have a nested cell, so like that interpolation is pretty fast. Is that, or like it's well defined? Is that what you're doing? Like it's similar to UBC style?
Yeah, so I originally had it coded to be like, general that could have meshes that are not nested, but it causes too much issues on the sensitivities. So now I just force it that it's only 3 meshes, and then I need to add an assert to make sure that they're all nested meshes. But yeah, it's UBC nested, correct?
Oh, okay, great. So that's like this is nested. I see.
Yeah, so all the meshes have all have the same extent. They're just refined differently.
Ah, okay, great.
Does that answer?
Yep, yep, that's actually great. Yep, perfect.
John.
Hey. Yeah, just working on the MT side of things here. Actually, Joe posted there that little overlook there of just doing the one matrix multiplication, and yeah, works well. On the test, or from the test side, it was like it usually runs at about 100 seconds, and now it's down to about 56 seconds. So,
Nice.
yeah, works pretty well. Maybe I'll try to do that on the DC side as well there, Joe. I think it applies.
Yeah, I mean it's one of those things that's the biggest speed up comes when there's like multiple types of receivers, because it already does that kind of option if it's just like a single receiver with a bunch of locations.
Yeah,
that's already kind of built into the P matrix itself.
Oh, that's
Yeah.
great.
That's how I set up.
Yeah, I don't think DC is the case. Like, so.
Yeah, I mean it could be. Like there's multiple
Yeah.
times. Like, there's no
Right,
reason
right.
you can't implement it like that, but it's just
Right.
not. a big mistake.
Yeah. But I think I'm not sure there's a person like putting multiple receiver into a single source at the moment for the DC code.
No, I mean I'm just saying it could be like that. So I mean, there's no reason not to.
Yeah. Absolutely.
But it's going to be most apparent in like, okay, the MT codes where it's like if you have real imaginary, like I said, real and imaginary components for each, like each impedance and tipper receiver, right?
Right.
And that's like 12 different.
Right.
In
Yeah.
3D, or in like the frequency domain if you have real and imaginary receivers, or or different components orientation sometimes.
Right.
Yeah, I'm really interested to see how you go, like what operation you're doing from the solution of the fields and mapping that to your actual data, and how you're defining your receivers in your data for the MT and maybe for the ZTEM.
Okay, yeah. Yeah, I pretty much just base it off of the tutorials that are already on there. But I can, yeah, as soon as I got something working here, yeah, I'll give it a shot there.
And are you doing a 2D simulation, or are you doing full 3D?
Full 3D.
Okay, cool.
Yeah, yeah, we just launched our QMEG system, which is kind of like the mobile MT. So yeah, that's just kind of pushing it on that, and then we're gonna go right to the 3D solution.
What's the frequency band, John?
We were trying to do from 10 hertz to 20,000 hertz. Right now, we're getting about 100 hertz to about 12,000.
Yeah, I mean, I guess ultimately where my mind is going is I'd love to be able to do a comparison of the 3D MT through SimPEG, and then the 3D MT from the GIF codes, because I've been using them a lot and developed them a lot. And I'd like to be able to find some kind of comparison, or find a way to be able to go back and forth.
Nice. I can fire off the MT. I've already done the comparison with the MT.
Oh yeah.
Yeah, with UBC to UBC to SimPEG, and then just about done with the ZTEM one too, so we can do a comparison on that. I got them in notebooks, so I can send them to you.
So when you define a receiver, would you define the component? You'd say like, I want the real component of ZXY, or the imaginary component of ZYX, and that's how you're defining receivers?
That's correct, yeah.
Okay. And you're not thinking about doing anything in terms of an arbitrary orientation, like you could have your let's say your X being along the northwest or something like that, or?
No, I have not actually. That's a good point.
Okay.
That's something we should, I think, try and do actually, like at the base frequency domain receivers, or like the base EM receivers, and then ideally just like inherit that up the stack.
Yeah, I mean, with the MT stuff, the raw data seems to come in and it's been put in a coordinate convention that has an alignment that's north, south, east, west. You may have to flip things around, but at least it's lying north, south, east, west. For ZTEM though, it's a long line and cross line, and that was a bit of an eye opener getting it into a format that you can invert and interpret. So I guess to make these things practical, which I guess is the point in the end, it's probably a good thing to consider as we're developing.
Fair enough. Yeah.
In sort of related vein, so with John, Sagi, and Devin, so since we're going to attempt to invert in 3D all the data that is collected in or at least some of the locations, what do we have for notebooks and perhaps tutorials and examples that could be used to help, well, for us to invert things here and then also to help other people, or what needs to be developed? Because John, you've been working with the 3D code, Sagi's been working with the 3D code, and maybe we could merge things and see if we get some good examples and tutorials.
For sure. Yeah, I can share what I've got there. Yeah, maybe Sagi, we can sit down sometime again and we can just look at what we got.
Like you mean the DC code, right?
Yes, yeah.
Yep. In SimPEG itself, like there is a couple of examples. I think Thibault put together, I guess, a long time ago, but still works, I guess. But yeah, we could put together something.
Well, we've got a data set. I mean, we've got a couple of data sets. We could use those as potentially an example to kind of carry through and see if, you know, the notebooks that Thibault has got or what John is doing or what anybody's doing. Actually, let's just take it from start to finish and then say, okay, here's a notebook that will be an example of how to carry out.
Right, right. So back to GWB, I just got kind of a couple of questions. What's the exactly problem that you're having? Like it's a memory issue?
So are you asking me?
Yeah.
Yeah, I mean, I have some data. I want to perform an inversion with, you know, the 2.5D physics. I've got a little over 20,000 cells and about 1,400 measurements, and I run out of RAM, and I've got 7 gigabytes, and I've got a pretty top-the-line laptop. And what Joe figured was that for every source, we're storing the fields, and we've got, say, 14 to 1,500 source objects. So we're storing 14 to 1,500 fields on that mesh.
Right. Okay.
So, yeah, that's more or less the issue. So the actual, yeah, the numerical solution for any right-hand side is not, like, that's not the thing that's maxing out my RAM. It's just storing a lot of fields.
Okay, got it.
John, you're scrunching up your eyebrows there. What sort of problems are you running? And 20,000 cells probably seems like a pretty small number.
Yeah, it's an absolutely small. It's an absolutely small like problem. 20,000.
So but the issue is that, okay, so that's this Wenner Schlumberger sound array, right? So every single receiver, every single data point has a unique source. So it's storing dipole.
Yeah, that's something that we haven't really thought about.
Right. So basically what's going to happen is, okay, we can at least speed up the forward operation a decent amount by taking advantage of the fact that, okay, we can just do a check where if there's more sources than there are electrodes, just switch it to a pole at each electrode and then combine the fields later. So that would speed up it'd speed up J times a vector, J transpose times a vector. We can do that operation inside those really quickly. That way, even though there's 1,500 data points, we only have to solve the matrix for that specific example 72 times. There's only 72 electrodes. However, we can't really get around it if we want to compute the full J transpose or the full J matrix rate, because no matter what, you have to do a solution for each data point. But at least it makes the other things faster, and we can take advantage of the reduced space of storing the fields. Because, okay, the issue was that there's 1,500 fields, 20,000 model cells, and then there's 16 wave numbers.
Right.
So it's all of those, like it's 16 times 1,500 times 20,000, and it gets, I think we were like looking at the fields object itself, and it was taking up like probably about 4 gigabytes on its own.
Yeah. Okay.
So that was that the fields object itself was what, 16 times larger than the sensitivity matrix.
Right. Right. So there are two things going on, right? Like one is memory issue, and the other is the speed, right?
Yeah. So
it's a trade-off. So the storing fields was sort of the trade-off for the speed. But
well, I mean, if you think about it, like, okay, if it's a dipole source, it's not that hard to just subtract 2 fields. Correct. But that operation is pretty quick, actually.
Yeah. Yeah. So there are like there are like number of ways to kind of make it speed up and also reduce the memory issue. But when so I was playing with just the octree code, but most of cases I don't need that many cells. Like 20,000 is a lot. So I was working on that Ansan DC data. Like if I generate the relatively kind of small octree cells, but I think I'm not sacrificing my accuracy. So I'm still doing an okay job generating the octree match. So I just need a couple thousand cells, and that's usually enough for handling this 2D data. And in such a case, so even this Wenner-Schellenberger takes longer because we got much more sources, but yeah, memory was not an issue for me. So yes, it kind of depends on us, oh, what do we really want? Because you may want to provide this app pretty soon to the GWB TOT people. So easy solution is like changing the current app, just use the octree code and don't use too much cells.
Yeah, I mean, if we're gonna get them to use octree meshing, we have to do a lot. We have to set a lot of the parameters ourselves because the level of technical knowledge is less.
But I mean, they don't need to do anything. They could use the exact same app, but we can just generate a function that for a given electrodes and set the mesh. So that's how it works now. So something like that.
I remember coming up with a little bit of things like that when I was working on doing inversions for the field camp down here. I made octree meshes for the 2D solutions. I can go back and look at that too.
Yeah, so actually using the octree mesh was easier to set the mesh up compared to tensor mesh. So
the 2D, it's really easy to set it up for the 2D mesh.
Right, you could just use this radial function and set the
from each electrode, just do a radial.
So yes, it's actually even easier using the octree code and faster. So we could potentially just stick to octree code, and that may solve most of the problem, I guess. And we can also do an optimization a little bit more and more. Doug, I inverted those data set, each of them and jointly, so updated the Google Docs, so take a look later.
Oh, okay, thank you.
Devin, do you have any other updates that you wanted to share?
Yeah, I have a few. So I went and looked at the SimPEG tutorials. We have ones on gravity, magnetics, and DCIP. So this would cover all of, I would say, the standard things you would want to do. You'd want to forward model in 3D. You'd like to try out tensor meshes and octree meshes. You'd like to think about topography. You'd like to do an L2 inversion. Maybe you'd like to do a reweighted least squares. So all of these kind of standard things that you would do for those 3 methods, we have tutorials for. And I went in and I fixed a couple bugs in the examples. So there's just a whole gallery of examples on SimPEG. So I've been trying to fix any kind of bugs or problems in those. So that pull request is going. Travis is timing out, and I've got a couple other little things in the doc test that fails, but they're more related to the not keeping up with the examples gallery as opposed to the tutorials I've made. So that's basically ready, and once that's put in, we can always add to it. And yeah, I've got some interest in the MT stuff. I don't know how soon I'll get to it, but I definitely like to be involved in the final product and making tutorials for that. With regards to the GWB stuff, the inversion tutorial video has been posted. So now they can basically do everything except for that Electro Pro 2 thing. So they've got the resources to take data from the iris, process it, and then invert it and get a reasonable result. And I made one of the TOTs an administrator on the Facebook webpage. Just long term, we're not going to be involved forever. Somebody needs to be. So I kind of chose somebody that was basically the best, what we thought was the best student. And then after that, I started
Are those tutorial videos, is the only path to them through Facebook, or is there some other way too?
If you have the link, you could get to the YouTube video. So I set the video as being public but not visible. And
Devin, is there any reason that you don't want it just public?
Because I haven't fiddled around with enough YouTube stuff to make it link to other videos that we use, and it was.
Because it'll do that automatically for you, because we know, because it knows which organization you're a part of.
Yeah, fair enough.
So if when it looks for relevant material, one of the first places it'll look is within that same YouTube organization. So if you're comfortable with it, it'll make it much easier for other people to find these if they're fully public. But that's up to you.
Yeah, I guess the other reason for this is right now it doesn't look like any of the content of the video will need to be changed, but I can't replace an old video with a new video. You have to fully get rid of the video on YouTube and then post a new one and update the link. And if people are getting used to putting the link into YouTube and something gets updated and it changes, maybe in the end, I'm just kind of encouraging them to go to the Facebook group as their starting point. Kind of.
I mean, I definitely see people, I mean, you see on YouTube many times of people just being like, oh, there's an updated version of this video. Like they update the description of the video and put a link to the new video there.
Fair enough. Yeah. So that's up there. Just need to make one for the Electro Pro thing. And then I took a stab at starting to fix the GeoSci labs to get those to be running on the simulation branch.
Oh, okay.
So the potential field stuff seems pretty straightforward. The DCIP is going to be quite an undertaking. And then there's a lot of utilities that are defined from scratch in GeoSci labs, but these utilities have actually been added to the SimPEG framework. So I don't know if I want to clean things up as I'm doing the stuff now, or just get everything to run on simulation branch and then think about cleaning it up after the fact.
I think that's a bit up to you, Devin. I mean, if there's some stuff that is super obvious, then it would be great if you can clean it as you go. But if there's some stuff that is a bit unclear or doesn't work out of the box, I think sort of getting it onto simulation in somewhat timely fashion is probably the most important piece, because there are other folks interested in the education side of things who are going to rely on them.
Yeah. Okay.
That was definitely my experience going through when I was trying to update all the examples to run on simulation branch, all the ones that were not the DCIP stuff. there are definitely times when I was like, okay, just, batch rename this, switch all these just to get it done quickly. But sometimes I'm like, oh, I see what they're doing here, and it's a utility, and I just switched out really quickly. Like, just, I would say first priority, just get it working. And if you notice things when you're going, you can either like make a comment in the thing like, oh, this has been implemented in SimPEG, and then just go on or something, or just change it yourself if it's easy.
Yeah, fair enough. But yeah, that's about it for me. I'm really keen on getting the tutorials merged to base simulation branch as soon as possible so that it will be updated as simulation branch evolves. And then, yeah, put some time into GeoSci labs as I do other work that I'm on the hook for.
So I have a question about so we have tutorials and we have examples, right?
Yeah. So
we need both. My basically thought is like, I need to have both separate things? Like, is it, you know what I mean? Like, just a kind of general question.
yeah, no, I've asked this question as well. And I guess last time this came up, it seemed like the examples was kind of this space where we would put things that we created to just show what SimPEG could do. People put time and effort into making these scripts or making these things, and you don't want to just get rid of it because you might be able to adapt it into something, or it might show an interesting utility and you just don't know where to put that yet for a learning resource. But the tutorials were really meant to be, showing somebody how to use SimPEG to solve a specific problem, whether or not it is a like synthetic forward modeling example, and in the end you'd like to create this survey and plot your results, or I'm going to start with some data and some topography, and ultimately I'd like to get an inversion result. So these are like very deliberate tutorials that are going to show off some very specific things through a practical work.
I definitely like that, and it's like, I feel like some examples should be more like that. And essentially it's like, okay, well, this example shows how to do a magnetic inversion. This example shows how you would do a general iteratively squares inversion, and then I don't know. You know what I mean?
Yeah.
Like, I feel like they would be like, they're almost like toned down examples and more concise. The tutorials are generally, at least I would think that.
Yeah. I wouldn't say that tutorials are overly concise. I'm definitely doing some things in it, maybe a little bit of the long way, just to show what's actually happening, to make it easy, because the tutorials should be easy to understand.
Yeah.
And then you would learn a fancy or concise way of doing something. But I've made sure that it's very commented.
Mm-hmm.
So I don't know, if you go in that branch and you build the website and you go into the tutorials, you'll kind of see what I'm getting at.
Okay.
One example set of docs that I really like, just as a point, is the Verde docs that Leo and the Fadiando project have been working on. And they sort of have this similar separation between what they've called the gallery, which is basically our examples, and then more a user guide or tutorials. And so that is just another example that we can look to for ideas.
Yeah, and I think one of the things about that examples gallery is it was also an opportunity to put the results of codes that we published or we used to publish papers. It's kind of an advertising and say, look at the actual practical work we've done, published work that was done using SimPEG. I think that was an idea as well.
There is a SimPEG research repository for that too. I know that Sogi, Lindsay, and we posted the example we published in that repository.
Yeah, I guess there was this idea at the beginning of the website was going to have kind of an introductory section, getting started, what is SimPEG, but also something that showed examples to hook people in. That was there was a few people that expressed that kind of interest on wanting to just show something up front right away that would pique people's interest and show that you can do a lot of stuff with this so that they decide to keep reading and actually invest their time. That was the thought, you know, say last year. I don't know if that's changed.
Sounds fine with me. I was just kind of curious. I don't think I would probably end up in that conversation at some point. So.
Yeah, it's a good question.
Well, Thibaut and Doug, I want to give you both a chance to provide any updates or questions or things.
For me, I'm working on a revision of the paper that I received recently, so it's taking a bit of my time. And I'm just gonna make the announcement today too. Is like we have mics that gonna defend not this Friday, but the Friday after, Friday the 13th. So we are gonna try to set a Zoom for that and have it filmed and probably post it on the YouTube channel too. So that's happening.
Is that which date, Thibaut?
Friday the 13th.
Dun, 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 dun.
Okay.
Yeah.
Wow.
What time? Do you know, Thibaut?
I don't remember on top of my head right now, but I can probably post it on Slack.
Yeah, that'd be great.
Okay.
What time do you say, Doug?
9:30.
9:30. Sounds good. It's Mark.
Doug, was there anything you wanted to bring up?
No, not really. I think we've been kind of gone through the DC stuff. So all the things that are connected with CWD are sort of the highest on the priority list. I must say that having information encapsulated in these case histories in 7-step format really does make communication much more straightforward. Ran and crew developed, took some data from a place called Papayan, and by even just doing the first pass of putting things into that case history format, somebody's able to kind of step in and just sort of scroll down and just get a sense of where the place is, what they were trying to do, and what the data looked like, and what a potential output could be. I mean, it really makes things quite efficient. So a high priority, I think, for the GWB project is to make sure that the first 4 case histories are done to the best we possibly can. And that means in some cases investigating 3D inversion effects, even though the data are collected along the 2D line. That's why I think if we have both the 2D and the 3D up and available through notebooks and some nice examples with respect to these 4 villages, that can go a long ways as far as advertising. It's not only useful as for Myanmar, but advertising SimPEG and things that we're doing elsewhere.
Excellent. The only other thing that I had to add, and then we can open up if there's other discussion items, is just a bit of a call out. If anyone wants to chime in, there's a number of points on the SimPEG education discourse channel of folks who are interested in getting involved and just sort of learning about some of our experience of using notebooks. And so if anyone wants to chime in based on experience with 350 or other like field camp, Joe, it'd be interesting to get your perspective on that, just to kind of have that conversation moving. I've been meaning to try and get some content there, but just haven't gotten around to it. So if anyone else is willing to just jump in and add a few thoughts, it'd be great to just have those conversations in motion. So yeah, and if anyone here also discourse is still a bit new. If you're ever running into something where you need higher permissions to do whatever it is you want to do, just ping me and I can manually update that. I've tried to give everyone who's on the call up your permissions to be able to do stuff, but if you're running into a wall or something like that, just ping me and I'm happy to give you whatever status it is you need. Perfect. Well, with the last 5 minutes or so, does anyone have other questions or things you'd like to bring up? Or Joe, Joe and Don, you mentioned you have potentially demos that you'd be interested in sharing.
Joe, go first.
Yeah, sure. I can show a few little things. Branch mine right now. Okay, that'll work. Just a few little quick things that I kind of show what I was talking about as far as a few little speed ups to make the code go a little bit quicker. Kind of show, or at least like I said, I've been working on like the low hanging fruit. I'll just show that really quick. Make sure I show the right thing. Yeah. Get some right. Okay. Okay, so essentially some of the things that we can like cut out some quick stuff on time as far as the simulation stuff. The fields object takes a long time to access in general, like especially if you're accessing it a single source at a time. Even like if you have a list of all sources, so like this change from like doing this to just storing all of them at once with the operator like that was actually pretty significant.
Yeah.
Just that single change like saved a lot of time.
Yeah.
The right-hand side in general was being constructed as a B and C ordering, whereas the solver, like the Paradiso solver, is wanting it to be Fortran ordered, so it can parallelize it efficiently over columns. So
right.
I mean, there's no like we can do that and just kind of have it set up that made that solution step go much like a lot quicker there. Just those are some quick ways that just things to think about if you're writing more code, like just kind of be aware, right?
Right.
Yeah. What else? Oh, I was kind of talking with Sagi a little bit about this. I made some simplifications in the operation for the sensitivity matrix. So instead of like doing the computing all the trapezoidal integration stuff, like recursively almost, like one step at a time, right, for each KY, just compute the weights for the trapezoidal integration ahead of time. And that makes the J vector like so much easier, right?
Yeah.
Like it's a lot cleaner than what it used to look like.
Yeah.
And that also makes it easier to kind of see, okay, where can we actually like switch stuff and speed some stuff up? That allows you to kind of, I was able to reorder all the for loops in this to get them back into a better orientation, a better order because of that, right? This is the kind of thing that I was talking about, like how, like a really quick way to implement that kind of, so the J transpose vector operation of summing them and then doing the solve. So you just keep track of these, you can sum them up like that pretty quickly actually as numpy arrays and then do the solution. From what I was seeing, it took actually longer to do this operation than it would do to generally solve things.
Yeah.
So just kind of looking at that. So then I started looking at that as well. And there's a few little things that I could do to speed it up. In general, but generally it's avoiding constructing a sparse matrix if we don't actually need to.
Right.
It takes time to build. It takes time to like construct even if it's a diagonal, it takes additional time, and we're not really using it to do anything.
Yeah. Yes. That was one of the reasons why I store it, because that getting the A derivative is actually that's the most expensive part.
Yeah, it kind of sucks. But so essentially what you can do is instead of using if you intend it to be multiplied by a vector or by a matrix, like a full matrix, right? Ideally, we just want to use like NumPy broadcasting to do it. So you can,
okay.
so right here, like if B was like a vector, right, this operation is pretty straightforward. And U is a one, you don't really need to do anything.
Right.
But let's say V coming in as a dense matrix, so it has a higher dimensionality. You can actually, let's say you can add on a new axis, like an empty axis onto it, which is like that operation doesn't really cost anything.
Right.
And then go ahead and do that multiplication again. Yeah. So that
And
that'll
Joe,
do that same
with
operation
that,
of the diagonal matrix times the vector.
with that, would you mind just including a comment there that just says like this is the same as doing S diag of whatever, just so that when like we compare sort of our handwritten notes of what we expect to see in the math, it's the same.
Right.
I mean, just as like a quick like.
Yeah, no, definitely. I'll put it in there. But like, it's just kind of, this is kind of neat, like little trick you can do.
Yeah.
I don't think a lot of people realize you can do this with NumPy arrays like that, right?
I did not know if you could do that.
You can just, like this literally, what this does is this just makes, so let's say U was like the shape like 500 comma something, right? After doing this operation, its shape becomes, it's like 500 comma 1. So then when you multiply it by something that has a shape, let's say it's 500 comma 1000, it broadcasts this, the values over these along each column, or along each row of the matrix. So you can, like, I found out that you can also do that with like the Dask arrays too that I was looking at. I talked to Dom a little bit about that one. It's an easier way to, instead of
The delayed, yeah.
yeah, like creating a CSR dot operation, delayed everything. You can just store, you could have just stored this as a Dask array and then done this to it, and it would have done the same operation. So it's a fun little trick you can do with NumPy arrays. Like, not.
Have you tried that, Joe?
I mean, I know it works. I tried it with Dask arrays, and I know it does what we would think it would do with Dask arrays.
That's great.
Yeah.
Yeah, because we had such huge memory spikes trying to do the CSR delays.
Yeah.
So I'll definitely going to try it. Yeah.
Yeah. But just kind of like things like, it's a nice, like I said, it's a neat little trick there. That was basically about it. There's kind of a few little things. So there was I just really quick, I know there was let me talk about the trapezoidal integration thing. So what I noticed before was that I don't have a good idea. So this is kind of what the operation looks like now. Before it was looping over a bunch of stuff, and it would, I think there was a small error in it, because when y was not equal to 0, I would get vastly different results. And this operation matches what like NumPy's trapezoidal integration would do.
Okay.
For the expected function. So like the expected function that we're trying to do the integral or the integrate, right? Yep. So this is a PF as a function of cosine, or a function of a thing. So we're trying to integrate with trapezoid is this RF times cosine like k times y, right? That's the function we're trying to integrate.
Right.
And this here matches, like I said, NumPy's trapezoidal weights when I couldn't get it to match with some of the other ones, like with what it was before.
Oh, really?
But it was like it said, it only came about when y was not equal to 0, because obviously cosine of 0 wasn't going to change anything.
Yeah. Well, like, we don't. Yeah, we're not like y is always 0 actually. Like at the moment.
Right. So that's why I was like, I just kind of played around. Like I was doing this because I wanted to get the weights to make other things.
Yeah.
So just little bit errors.
Yeah.
Okay. Sorry, I'm talking.
That's good, man. It's all good stuff.
Do you got anything quick, Tom?
Yeah, I can spin the demo. I was just looking at the code. When we're storing J, do we actually have to store fields? Can we just, because we're storing it and we're slicing it after. I just wonder if we can just like compute the fields right on demand. But anyway.
I mean, it's certainly something you could do. Yeah.
Yeah, that's actually not expensive.
Yeah.
And then we wouldn't have to store the whole thing. Anyway, so this is just the quick demo. It's just a gravity inversion using 2 tiles, right? So tile 1. You guys see this? You see my screen?
Yep.
Yeah. So it's tile. Split the survey into 2 parts basically. So that's the global mesh, local 1, local 2, and then the inversion is going to spin. And then yeah, so we don't see the good thing is that we don't see the split, right? The model is symmetric, and we don't have like a drop off. So that looks promising.
Okay.
That's the same. That's roughly the same map that I've been using on my personal branch. But yeah, that should give it for everyone.
So, where's the code that generates the map? Dom?
1 sec, yeah. Oh, you mean
In the
not
script. In the
Oh,
script.
in the script. In the script. So first, it's a loop. You need to create your meshes first. Okay.
I see.
And then once you have your meshes, you create your global mesh. And then this is pretty important because that will guarantee that your global mesh will always going to have the smallest cell size. You always want to homogenize down the global mesh, not the other way around.
Right. So you're generating like a very fine mesh first, like a large fine mesh first, then like
No. You just so you have your local surveys. You're gonna use like, let's say, your topography as your initiator to initiate the full extent of the global mesh, but you're gonna refine only on the local surveys.
Right.
Okay, that gives you your local meshes.
Right.
And then you're gonna create your global mesh by just grabbing the cells of each local mesh to refine.
Oh, I
Basically,
see.
make sure that the smallest cell at each location in every local mesh is in the
You got it.
global mesh.
Yeah.
Got it.
And then after this is just looping and creating simulations. So you just loop through your surveys, and then create a tile map.
So for your case, like you're not gonna generate the mesh for each data, right? Like here, you're gonna just group your data somehow, and then use like several mesh. Is that the idea here?
Yeah, well, I mean, nothing prevents you from creating one mesh for
Correct.
one mesh per point, but it's kind of a trade-off, right? Eventually, you're gonna end up having to store a lot of meshes.
Yeah, which is not that cheap, I guess.
No, like yeah, I tried with a few problems, and it's a bit like an optimization curve, you know.
Yeah.
At the beginning, you're gonna save a lot of time and a lot of memory, but eventually, as you have a minimum number of cells that you need for each points, so you're gonna end up like just costing you more time to generate and store those meshes.
Right. Okay. So I mean, like, what kind of the design of this tile map is like probably handling, let's say, several meshes, and is that sort of the scope? Like when you're running a single inversion, you may generate like not thousands of mesh, but like 10 mesh or 6 to 7 mesh or something like that.
Yeah, I think like for the potential fields, it's easy because we just tile it as a function of how much memory we wanna use. For DC, I think lines. For MT, it's probably going to be over frequencies. So yeah, that's kind of the idea.
Excellent. Thanks,
Someone
John.
has a very heavy door.
Yeah, that's our office here. Perfect. Any other last minute things before we wrap up?
Not here.
I'm gonna get the method stuff done today and put it in. So there'll be a lot of pull requests coming in really quick.
Excellent. That's exciting.
Make it fly.
Perfect. All right. Well, have a good afternoon, everyone.
Great. Thanks, guys. Have a good one.
Bye.
Bye-bye.